Okay, here is a very nice proof question. F of x is bounded, and f of x is differentiable in an entire real number. And if absolute value of f of x minus f prime of x is less than or equal to 1, prove that the absolute value of f of x is less than or equal to 1. Okay, you may try yourself before I come back again. Okay, this is my way of a proof. I let g of x is equal to f of x over e to power of x. Well, since e to the power of x is a non-zero number, therefore g of x is well defined, and the f of x is bounded, therefore g of x is also bounded. Now then g prime of x, the derivative of g of x with respect to x. So I use here I'm using the quotient rule. Right? So the derivative of f of x e to the x minus derivative of e to the power of x times f of x. Yeah, this can be simplified by reducing the e to the power of x becomes e to the power of x, and f of prime of x minus f of x. Yeah. Then the absolute value g prime of x will be equal to the absolute value, because denominator is non-zero and is always positive. Therefore, this is the absolute value g prime of x minus f of x. According to the given condition that this is less than 1, right? So this is less than or equal to 1 over e to the power of x, which is equal to e to the negative x. Yeah, everything makes sense. So when you do proof, it's a very strictly, you must be very careful that every step is making sense and everywhere is valid. Now then g prime of x is between e to the power of a negative x and then negative e to the power of negative x. So that's correct. Now then I'm using another dummy variable, g prime of t is between e to the negative t and negative e to the negative t. See, the reason I'm using t instead of x, because I want use the integral of g prime of t from x to infinity. See, it would be less than or equal to integral from x to infinity e to the negative t dt. Is greater than or equal to negative e to the negative t dt from x to infinity. See, I must be very careful. Okay, this one is equal to g of t, right? Yeah, this will be g of t from x to, this will be negative e to t, negative t from x to infinity. That would be positive e to the negative t from x to infinity. Uh, then, then what? Then this would be g over t. It would be f of a t, right? Over e over t from x. This will be 0 minus will become positive, right? Positive and negative x. This will be negative e to the negative t. Now, when t is infinitive, f over t is bounded. Therefore, the whole thing will be 0, right? So this will be equal to f of x over e to the x. Negative, right? Negative. Less than. Then I multiply by e to the x, right? This f of x less than or equal to 1. This is negative 1. Which means that f of x absolute value is less between 1. See? Very nice proof. This is very good proof. Thank you for your watching.